Welcome. I'm so glad to see so many folks here this morning, especially early on the first day after I know there was all kinds of SQL karaoke shenanigans going on last night, which I hated to miss out on. I had to be a grown-up and make sure I was ready for you guys this morning. We are going to be talking about window function fundamentals today. Not anything about the Windows operating system. These are window functions in T-SQL. So if that was not quite what you were expecting to learn about today, then there are tons of other stuff going on that I don't want you to miss out on. So I won't be offended if you want to hop up and go find something different. And you know what? If I plug my USB stick in, my clicker works a heck of a lot better. There we go. Housekeeping, mute your cell phones, guys. Come on, really? Do we have to ask you to do this? You don't have to turn them off, just silence them. That's all there is to it, easy peasy. And Pass would like for me to talk to you about a few things that are available here this week. Definitely get involved in your local user groups. They are a fantastic resource for knowledge and free training and networking, and you'd be amazed at how much value there is to be had from your user groups in your hometown. And if you don't have one nearby, check out the virtual chapters. There are tons online, and if you go to the SQLpass.org site, you can get a list of all of those that are available. Another thing that you can do for free training is SQL Saturday events. They're all over the country and spreading all over the world. And if you go to SQLSaturday.com, you can find an event near you. And they'll be full days of training, usually 4 or 5 tracks long. And again, a great opportunity to learn for free and to make some good connections. 24-hour Pass events are recorded and web-streamed events by SQL Pass. They happen every 6 months or so. I did a preview for this session on the 24-hour Pass Summit preview a couple weeks ago. You might have caught it. SQL Rally. It's kind of in between SQL Saturday and Summit. It is a paid event, but it's not quite as big as Summit. The next 2 are coming up in Stockholm and Amsterdam. I'll be speaking at the one in Amsterdam in the 1st of November. And if you're already here, you figured out that the pinnacle of our SQL events is, of course, the Summit session. So there's so much going on this week, and the best way to make sure that you don't miss any of it is to buy the recorded sessions on the little memory stick. I remember my first Summit 4 years ago and was completely overwhelmed with the choices available and wanted to see everything, all of the sessions, all of them. And it's just not possible. You have to sleep at least a little bit. So if you buy the recordings, then you can go to the ones that you're really, really interested in, but you still have the material to review when you get home. So that leads into our session evaluations. These are incredibly helpful for me. Your constructive criticism really helps me know what I got right and what things I need to improve on so that you can learn better next time. So if you take a few minutes, I know it seems like a hassle, but the effort is greatly appreciated. If you would take a few minutes to fill that out today, Pass has made it easy for you. You can just go to passsummit.com, and when the homepage appears on the right-hand side, about halfway down, you'll see a little blue icon that looks like a bullseye, and that'll take you to the session evals page. And you can also use Guidebook if you're using your Guidebook app to get those. So that's the last of the housekeeping items. This is a little bit about me. I used my Twitter profile because it's short and sweet. I've been doing SQL Server stuff been doing IT stuff since '97, but full-time SQL Server since about 2008. I'm from Nashville, Tennessee, and wow, has my accent come back strong since I've been here in Charlotte this week. Anyway, I've been in Boston for about the past year and a half, and I'm on my way to the Netherlands at the end of this month, so all sorts of big changes going on. I use my Twitter profile because I can't stress enough the value of the SQL community presence there. And if you've been following the Summit 13 hashtag, I'm sure you've seen all sorts of stuff going on this week. And there's SQL Help and SQL Pass, and you even see a SQL Family hashtag. And it's a great way to get involved with the community and not only to get expert help, but to stretch your networking bandwidth. And if you're kind of afraid of Twitter and not sure how to get started, download Brent Ozar's Twitter book. You can just Google Brent Ozar Twitter book and it'll come right up, and he's written a great free PDF that'll help you get started along with that. So now to the heart of things. This is what we're going to do today. I want to cover some of the conceptual items concerning window functions first, what they are exactly, and how they work from a logical perspective. Then I want to address the practical side of things and look at what functions allow the windowing syntax and some of the tasks that they can accomplish for us. Now you might feel like we're starting out a little bit slow, but hang in there because each section builds on the next, and I guarantee we'll uncover some things that you might be surprised to learn. So, what's a window function? It's simply a calculation that is applied to a set of rows defined by the order clause. What does that mean? They're mainly used for analytical purposes, such as calculating running totals or moving averages. They can be very useful for working with temporal data, anything that's interval based. We're definitely going to look at some of the cool things that we can do with window functions, but first, to do this right, we need to spend a little time talking about the inner workings. Now, the over clause is not really as straightforward as it seems. After all, there are three parts to it, and they allow us to customize the way the function is calculated. To make things worse, the customizations have different effects depending on what type of function we use them with. So things can get confusing if we don't lay it out right from the start. So let's do a review of the concepts behind windowing. Most of you ought to be familiar with using grouped aggregates already, hey? You guys have done counts and sums and okay. A grouped function returns a single expression per grouping column, right? So rolls up and we only get the one line item. Now, I know everybody in this group has been out to dinner with a crowd of people. And if you haven't before, by the end of this week, I know you will have. So when you get to the restaurant, what's the first thing that you do? Well, you can't order. Somebody's got to go up to the hostess stand first, right? You get together and somebody's got to count. Somebody's got to go up to the hostess stand and tell her how many people in your party. Well, it's a scalar operation, right? You don't all go up there and tell her. Only one person goes. Everybody else hangs back at the bar or in the doorway. And so one person is responsible for reporting the aggregate for the group. That's exactly how grouped aggregations work. The calculation's made for all the members of the group, but only a single row gets reported. Now, at the end of the night, the hostess list might look like this. It was kind of a slow night for them. They didn't have a whole lot of folks coming to dine, but oh well, maybe it's a tiny restaurant. We've got the information for each group as a whole, but that's as granular as it gets. What if we're interested in more than just the group information? What if we need information about the individual diners? Well, then we're going to have to gather our information in a slightly different way. Instead of one group representative going to the hostess desk each time, each member of the group needs to check in upon arrival. By the time we've all checked in, the hostess list might look a little bit different. We still have the information we'd have gotten from the grouped aggregate. The number in the party is the same for each diner, right? But we've got the detail about the diner, the first name and the last name. So the first takeaway here is that windowed aggregates allow us to report a grouped aggregate without losing the granular detail of the raw data on which we're operating. This is a key difference between grouped aggregates and windowed aggregates. That's why you'll sometimes hear windowed functions called set functions. We're operating across the entire set of members in our output. There are other differences, of course, but we'll talk about them a little bit later in the session. Now, remember I said that a windows function is simply a calculation that's applied to a set of rows defined by the over clause. Well, this is what I'm talking about. This is the over clause as in its very simplest form. We've used the pure default and told SQL that we want the window that we want it to work on is the entire result set of our data. No bells, no whistles, no customizations. So in this example, our window is made up of the set of rows in the green brackets there. Logically, I'm going to start with my first row and count how many belong to my window and report that value as my aggregation, and so on for each row in the window. So remember, I need to stress this happens logically. It's not actually physically working row by row in the background, but from the logical perspective, I'm going to calculate row per row. Are you with me on that distinction? Okay. So the aggregation being calculated for each row is a key point because that's what makes understanding the customizations that we can do with partitioning and framing and ordering makes that make a little bit more sense. So let's build on this idea. As we mentioned earlier, the overclause has 3 parts to it. The 3 parts are partitioning and ordering and framing. Now, all the functions support partitioning. Either if it's not specified, it just uses the whole result set as the partition. But if we've declared a partition, then any of our aggregate, ranking, distribution, or offset functions can use partitioning. Explaining that's going to be straightforward. All functions also support ordering, but they do it differently depending on what kind of function they are. So that gets a little bit confusing, but not so bad. The thing that makes the difference between how a function processes ordering is whether it supports framing or not. So I want to skip ahead and talk about framing before I talk about ordering, because that will make the ordering part make more sense. I hope. So we'll see. First, let's talk about partitioning, because that's the easy one. We're going to go back to our hostess log example, except this time I've got all the diners for the evening in my select output. Plus I've added their arrival time. Everybody, that's good size in the back? Okay. Now, if I did my count star over on this set, what would we get for each row? I want to count how? 17, exactly, because I'm counting all the rows across the entire partition, the entire output. So each row would have a count of 17. You following me? Okay. Now, this works because we didn't specify a partition. So let's see what happens if we do add one. What if we partition by party name? Now I'm telling SQL Server to calculate on a subset of the main partition. And if I look at the overB party, what's my count going to be for the rows in the overB partition? Exactly. And for Pellegrin, we'll get a count of 3. So because we've broken up the result set into parts, now our calculation is occurring over a smaller set of rows. That's the main concept behind windowing, and partitioning lets us enlarge and shrink the window that we're working on. So far, so good? Okay, y'all got to holler if you have questions, because I'll just keep talking. Now, you can add further columns to your partition if you want. Say we add party name and diner last name as well. Now, our party just shrunk by a row because we had to kick Kyoko out because she didn't match the group criteria. Make sense? Before, we were only saying by party name, so all 3 Pellegrins had the same party name, so cool, they're part of the same group. But when I ask it to do by party name and by diner last name, I've just added an additional key column, and now, because Kyoko has a different last name from the other 2 Pellegrins, she doesn't fit in the window any longer. So we can add as many columns as we want to get that detail as granular as we need, even down to a single row level if our solution required it. So that pretty well covers partitioning. Any questions before we switch to framing next? All right, I don't see any hands. So what do we mean by framing? Framing is the customization that we can use to control how our function is calculated in relation to the partition itself. We got to think about this for a minute. It can be row-based or value-based, and it can be a little confusing to think about. So let's go back to our dinner goers and see if I can give you a concrete example first. I see a question. Sure. He asked that I repeat the definition for framing. And if I forget to repeat the question, you guys remind me because I'm bad about that. Framing is the customization that we can use to control how our function is calculated in relation to the partition itself. And it can be row-based, or value-based. And our example next is going to illustrate what I mean by that. So if we look at the Tepper party, We can see that we've got four folks in the group here, and that they all arrived at different times. And Warner, he got there first, so he went on up to the hostess stand, and he said, hey, I've got four folks for dinner. Can you put me on the list? And she says, yep, cool. She certainly needs to know the total for the group, but she also needs to know how many people are already there, because she doesn't want to seat them until they've all arrived. So when she asked, so how many are you here already? Warner's just going to tell her 1, right? Because if we think about the frame boundary being Warner plus everyone else in the group that precedes Warner, all of a sudden his position in the group becomes important to the calculation. There's just him and nobody else before him, so his count can only be 1. Are you with me on that? Okay, so we're thinking just in terms of position here now. When Hank and Katina arrive, they get there at the same time, essentially. We're not, counting this down to the microseconds. So they both walk up through the door about the same time. But for some reason, Hank gets to the stand before Katina does. Maybe she stopped to talk to a friend on the way in. So what do you think Hank's going to report as the count for how many in the party are already there? I hear 2. Oh, I hear 3. Yay! Y'all are with me. This is where it gets tricky. Both 2 and 3 are correct answers. Let me explain why. It depends on how you've defined your frame boundary, or defined your frame in general, actually. Remember I said it could be row-based or value-based? Row-based framing works this way. If we define our frame as the current row plus any preceding rows, then our count is just 2. That makes sense. But I should stop and point out here that ordering is inherent to this process. Framing can't happen without order. Otherwise, you'd have no idea how to determine your position in the partition. We'll go into more detail on that, but for now, just keep in mind that we're ordering on arrival time. If we use a range-based frame definition instead of a row-based one, range is going to want to include not only itself, but also any member rows with the same value as me, the same ordering value as me. So if we define our frame as the range of all the preceding rows plus the current row, and again, we're talking about range, we have to include any rows that have the same ordering value as the current one. So not only do we get Warner, because he precedes me, but we also have to bring in Katina because she's got the same arrival time value. So that makes our count 3. Does that make sense how the difference there? The thing that trips people up here is it's got this distinct values that cause the problem. Because range is based on the value and row is based on the discrete position. If I have distinct values, then I'm going to get the same results if I use range or row. It won't matter. But as soon as I introduce duplicates, I may have to adjust my ordering key to enforce duplicates, or I may have to explicitly declare a row-based frame so that I tell it, don't worry about the fact that there's duplicates, just go based on your exact position. And our demos coming up next will make that a lot more clear, I think. But this is a place that folks get lost in a lot, I think. So I can't stress it enough that range is value-based and row is discrete position-based. So any questions on the concept of framing? We'll go into more detail with the demos. All right, we're doing well on time. The last thing we need to talk about before we start looking at code is ordering. Now, as of SQL Server 2012, there are these 4 types or groups of functions that can support windowing. Now, I wanted to specify SQL Server 2012, and my discussion today is going to be in the context of what SQL Server 2012 can do. At the very end of the session, I've got a cheat sheet for you that'll show you how these functions grew from 2005 forward and what things are supported and what aren't, for terms of backward compatibility. But for today's session, we're just going to talk about 2012 features. Now, all of these guys can take an order by specification. But again, it can mean something different to one group from another. And the key is to knowing which is knowing who supports framing. Ranking and distributions do not. They don't support framing at all. They're purely order-based because they're calculations. How do you calculate a rank without putting something in order from smallest to largest or largest to smallest? There's no way to do that without an order. So if you try to write queries with, say, a row number or a rank or a dense rank and you leave out the order by clause, you're going to get an error. It's just, it's required. You don't have to have partitioning, but often you will. But for ranking and distribution functions, order by is required. Now, the aggregate and offset functions are the ones that do support framing. Now, for them, instead, where ranking and distribution, order by helps create the calculation. For aggregate and offset, order by helps determine your position in the frame that we just talked about. Where am I in the process of the calculation within my set? So, when we write a query, and here's the sneaky part, when we write a query that supports aggregate or offset functions, and we put in an order by statement, but we don't explicitly define our frame, SQL Server is going to use the default frame. If we just do partition by group party name, order by arrival time, but haven't said anything about the third part with the framing, SQL Server is going to say, yep, use range between current row and unbounded preceding. So me and everybody before me. And do it by range, which means we're going to do it by values. So if I have distinct or duplicate values, I might get some wacky errors. So that's why I've really been pounding on this, because you've got to know whether you're dealing with distinct or duplicate data, and if duplicate data is okay, then you don't have a problem. But if your numbers don't come out quite like you're expecting, you might need to do something different to explicitly define that frame. So in the demos, we'll make this very clear, and it's easy to fix. So, any questions about the over clause, either the ordering or any other of the things that we've discussed before we go to the code? No? Okay, don't be shy. No question? Okay, yes. How does with ties affect? In the frame boundary definition? I don't know. I don't know. There's no syntax to say with ties, so we'd have to play with that. That's a good question. We'll have to figure out how ties are ties. Usually you break the ties by creating uniqueness. So that's probably the best. There's not like when you do a select top with ties. I guess I do know the answer to that. We handle ties by forcing uniqueness and deciding from the business perspective how we want to address those. Does that answer your question? Okay. So I'm going to attempt to get my display to switch to SQL Server so that we can see the code. And I think the best way to do this is to just turn off this PowerPoint and close this window and open this, which means I'm not going to be able to go back to, demo 2 starts here. But that's okay, we can manage. 11, we have till 10:45 to what, 11:15? Sorry? Noon, okay, good, we got plenty of time. All right, so let's open up SQL Server, and I want to duplicate my displays, personalize, project to a second screen, duplicate. Yes, you guys can see me, and my real estate is narrow, so we will have to use lots of zoom it, because I won't be able to put things side by side like I'd hoped. So with our first demo, I want to go back to our counts that we're familiar with from our story. Just the hostess log that we've been working with, and I've got some data in a single day table. I've kind of condensed the information so that it's for clarity's sake. This is not exactly real world data that we'd be working with. We'd have lots and more rows, but to explain the process, it helps if we can eliminate variables. So let's look at our raw data here. And there's our 17 diners for the evening that we were looking at earlier. And now in this case, we put, excuse me, I want to point out that we used no partitioning, no ordering, or framing. We just did our vanilla count star over. So let's go to our second script and add some partitioning. In this first example, I'm going to partition by party name only. So see, I've got my count star function, and I've told it by using the over clause that I want it to be windowed instead of grouped. And so I've put the first part of my over clause is partitioned by here, and I've not specified anything else. So when I run this, I get my counts like we talked about by each individual group of party names. So for this next section, I'm going to simulate those partitions individually just by filtering on party name. Exact same query, but I just want the three guys here so we can look at what happens when we start playing with the order by. So in query 3, which I'm going to open up side by side here, hope I can make this work with a tiny screen. All right, so we've got, I think that one, is the font size good in the back? Okay, y'all have to tell me if you can't see. So now, if we add partition by and order by, we still are going to partition by party name, but now we've introduced an order by clause. We haven't explicitly set our frame, so we're going to get the default frame of range between unbounded preceding and current row. And I'm going to look at just Mr. Overby's group here, and I can see that I just get a count of 5 here, and just like I have on the other side. So everything looks okay, except that everybody arrived at the same time in this group. What happens if we look at a group that don't have the same arrival times? So if I hit F5 here, I can see my other groups. And to see how my counts changed, I don't really have the distinct values that I expect to see because I've got 2 duplicates here. And my duplicate, if I really just want the count of when they all arrived at exactly the same time, then the 5's right. But if I want to see how they added up as they came in the door, then I've got to do something a little bit different to get that distinct 1, 2, 3, 4, 5. So this is how we can fix that. Sorry? Oh yes, I can. The first query, the second one is filtered by party name price. I'm still partitioning by party name and ordering by arrival time, but when I run that, because these 2 guys arrived at exactly the same time, their count is 3 because we're counting on the value, not the row position, because we didn't specify our range and we don't have uniqueness. So let me show you how we can fix that. I want to run all of these again and open up my next query, drag this guy over here because we want to be able to compare. So before, we were getting the full count for all the partitions. And now we're starting to see the sequencing happen. And because we've got some duplicates, our sequencing is a little bit off. So the first thing that we can do to solve that is to force a unique ordering key. So if I'm looking at my first group, my Overby group, what would I have to order by to guarantee a distinct row?
First name.
I could just do first name because they've all got distinct, hey, I made it more complicated than I need to. Cool, I said arrival time, party name, last name, and first name because I wanted to make sure it was distinct. But I do believe if we take these out, wait a minute, but we are concerned about who did get there first. No, see, we can't because they all got there at the same time, so it really doesn't matter. So let's do just first name. I like this. Y'all are paying attention. So if we forced a unique key. Look at that, 1, 2, 3, 4, 5. We only needed the one value. So when we're debugging our code like this, it's important to know what's the business rule? What problem am I trying to solve? It's kind of hard to with examples like this because we're just making stuff up, but you have to be thinking in the back of your head, what things guarantee uniqueness for me? And that will help you determine which columns to use. In this case, it's possible that we have some folks with the same first name, but maybe different last names. So we would have to use a different combination of ordering keys to force our uniqueness. In our second group, we only needed arrival time and last name. And in our third group, we didn't need to force uniqueness at all because they were already unique to begin with. So if we know for certain that the rows that we are dealing with are definitely unique, then it doesn't matter whether we specify rows or range. Again, you have to know your data and know the problem that you're trying to solve, and it's not so much that one way is better than another, it's just what tool solves your problem with the correct answer. Does that make sense? Yeah, I see a question. We'll talk about that in the, I've got another, that is a great question because I have a demo for that coming up. Then I think that will answer your question. And again, it depends on what you're trying to accomplish. If you only want the group to aggregate and you only need to hit once, just run the group by and be done with it. What's the difference between this and using row number? This is an aggregate function. I'm using sum. Row number is a ranking function, and we've got a demo on ranking functions too, and I hope that will clear. Ranking is different from this is I'm doing a count, so it's not the same as putting something in order. And ranking is going to give a distinct value for each new member, where dense rank will give a distinct value for each group of members, and it's just not the same at all. It's a rank as opposed to a calculation. So when we look at the ranking demos, I think it will clarify for you. So we can go for, I think I've got one more in here. I do. So that last example showed how we could get our counts to come out contiguous by forcing uniqueness. This example shows how we can explicitly declare a rows frame and just make this process much easier. Instead of using the default range unbounded proceeding, I'm going to tell it rows instead because I don't care about the values. I only care about the discrete position in the group. So for all three of these queries, I could leave just my order to arrival time in my order by statement, change my framing so that I've added rows unbounded proceeding. And I'm going to run the same three queries, but I've explicitly declared my frame. And now my counts come out contiguous like I would expect because I told it, forget it, the values are too confusing, I've got duplicates, I don't want to figure out, I don't know how to tell which is which, so just use rows, and that gets me close enough. So again, you kind of have to choose which. I would err on the side of declaring my frame so I know exactly what's happening in my code rather than relying on, oh wait, is this default behavior that I'm not sure about? So my advice is to explicitly declare your frame unless it's just something, especially in production code. If it's just something that you're doing to figure data out, it's not necessarily as important. But the more things that you can do to make your code as precise as possible and easier for folks to follow later down the line, the better. And by explicitly declaring your frame, you'll make it easier for folks to figure out what was in your head when you were writing the query. So that is, yes. Sure. Yes. And all of these demos I've got a download link available on the PowerPoint, which I'll have to figure out how to bring back up. And they should be available for download on the Summit site as well. I know I uploaded all of that stuff to those fine gals that are working their back ends off today. So it should be several different places that we can get a hold of it, and I'll tweet it, and it'll be on my blog. So all the code will be available. So that is count. The whole reason I used count because it was an easy function for us to get our head around, and the main point of those demos was to show how the range framing and row framing behavior can switch on you if you've got duplicates. So if you guys got that, then we're good and we can move on to the next thing. So I want to close all of these. I want to save my changes. All right, now I want to open my next demo, which is going to talk about sum. Now, our first demos, we were working with count. We used the short syntax for the frame definition. We define our frame, we say it's a rows frame or a range frame, but there's also a boundary definition. And when we say unbounded proceeding, we're using the short syntax for the boundary. And that means that it will include me and include everybody behind me. There is a long syntax that we'll want to look at. If I look at my raw data here in my full hostess log, I've got several days worth of data, arrival times, and the sales total, how much they spent for each per person. Let's say I want to get a running total for the night. So what columns would I need to partition on to find the total sales per evening? Arrival date, yes. Good. So in my next query, I'm just going to add a partition by arrival date. And when I run that, I should see the full sum for the entire arrival date. As soon as I switch to 9/22, I get a different value. And I made these all round numbers so they'd be easy to add up by 10 so we could check our math. All right, so you guys are with me on that, yes? All right, so that looks like something that we could do with group by. If that's all we need, group by statement is fine for that. But what if we wanted a running total as the evening progressed? Then I'd need to add some framing to do my calculations to get them to order up or add up based on arrival time. So knowing what we know about our uniqueness issues with arrival time, what columns do I want to order on to guarantee unique rows? And I'm going to give you a hint that the log ID in here is unique. So if I want to order my rows so that I'm forcing a unique row for each partition. But I want to add them up as the evening progresses. Arrival time first and then log ID. Good. Because log ID will give me that uniqueness that I need to sort out the ties between my times. I had those two 1805s. I know that the second, even though I didn't record milliseconds, I know that she got entered it. She had to have come next because her log ID is one higher. So, it's not exactly precise, but I can infer from the log ID enough to get my report out. So, I've partitioned by. And because I have in this one, I wanted to also add up by party name. So I asked my question badly because I wanted to add up as the party progresses as well. So let's run this. Here we go. So if I look from 9/21, yep. So as the evening goes, I've got the first party, and as they arrived, I can see their total coming up to 120. And then the next party starts, and their bill gets added. And then by the end of the night, we get up to the 290 that we were expecting for the full group. And we know we're doing it right because we start over again when we get to the new partition. The new partition segment starts with the new arrival date, right? Okay, that's easy enough. In that case, I left out the explicit range or frame definition. In this example, I am specifying rows unbounded proceeding using the shortcut syntax. Unbounded proceeding means me and everybody behind me. And I've told it rows because I don't want to mess with trying to figure out distinctness. It doesn't matter to me. I just want to add them up by arrival time. So, sorry? Mm-hmm. Okay, this is interesting because we're thinking about it in terms of, I mean, the current row, and then in temporal data, everybody behind me because they came earlier. Yeah, this is where this whole framing thing gets confusing. So let's see if we can step through. We've got June. There's nobody coming before June, right? June's the only one in the list, so her value is 50. So now, when we get to the next member of the June party, they spent $10, so I'm going to add their $10, take myself plus the person that's behind me, and add that up to 60. And then, so does that help clarify? How would you phrase that? Okay, so that's interesting. That's a semantic issue that I'm not sure how to address, especially depending on the way that your brain thinks about things. Yeah, do I push that appointment back or do I move that up? I hate that. Can we move this forward? Well, do you mean you want to do it earlier or do you want to do it later? That's the kind of thing that we're struggling with here. So, sorry? Okay, so when we look at the long syntax, let's go to the next demo because I think that might help. The short syntax is what confuses people, I think. So let me open, that's good dialogue to lead into the next query. This long syntax says rows between unbounded preceding and current row. So you have to know what your definition of preceding is. That's why the order by is important. Because I'm ordering by arrival time, anything with an arrival time less than me precedes me, right? Had I flipped it and done order arrival time descending, that flips it on its head again, because then it'd be everybody with an arrival time ahead of me. So your ascending and descending can mess this up too. So I was trying to keep it simple, but that good question helped illuminate that. So your definition of preceding purely depends on your order key and whether it's ascending or descending. So not only can we do unbounded preceding and current row, which is going to give us the same results that we were looking at before. We get up to 290 down here and then we start over again at 20. But we can actually shrink and enlarge those boundaries. I can tell it, give me between one row preceding and one row preceding. Only give me the row behind me. And that will give me my previous sale. I'll still get my sales total, which I'm going to name current sale here, and then I'm going to use my partitioning and tell it my window and tell it where in the frame I want it to grab that value and grab the one that's one behind me, and that's all I want. So when I run this, I get my sale, and there were no sales before me, so I get null. And for this guy, he was 10, but they sold $50 before he got there. So I'm not doing a running total anymore. I'm just I'm picking a specific value out of the frame of my partition. You could, yes, and we'll talk about that when we talk about lag and lead. But the cool thing here, next val and last val have a default boundary. They default to one following and one following and one preceding and one preceding. You can't increase them. In this example, I could say between two preceding and two preceding. And rerun that, and now it's not really the previous sale, it's two sales previous. So I have a lot of flexibility in how many, if I had data that I knew came in monthly and I wasn't missing any months, I have values for every month, I could get one value for 2 months ago, one value for 3 months ago, one value for 4 months ago, all in my same query. which is kind of cool. And that's going to touch on the question about why not to use group by for some of these things that we're going to show next. Here's another syntax that we can do. Instead of doing specific rows within the frame, I can tell it do between unbounded preceding and unbounded following. Give me the entire frame. I don't want you to pick a specific spot. So when I do that, I'll still get my current sale value, but I'll also get the value for the entire month. This is useful in a report if I need to do an average. So I've got all the information now that I can just feed into reporting services, and I can put a calculated field on that report, and boom, I've got my average there. I don't have to do a bunch of calculations in my T-SQL code. I can let the report builder do that for me. I've given the developers the raw data they need to create the calculations on the other side. Yes?
I like to use the preceding,
Mm-hmm.
put a number in there. But how can you pick a starting point? It's in the middle of the table somewhere.
Yeah.
Like if you had,
You can only, okay, so you can only choose within your frame, within your partition, and then if you wanted data from a different partition, then you're going to have to start adding subqueries to bring that together. The question was, how do I get rows farther away?
let's say that you have a table that just contains one value per month, and you have 10 years of data, one row per month.
Okay.
Okay, so you have 120 rows. And you want to use the preceding, I like that you can pick, you can hardcode that as 12 months. Say you want to get annual data, you don't know where the user wants to start.
Right.
The data. So you have a variable. I usually do it.
You could do some paging to get, yeah, there's some paging techniques that you would have to construct your base data first. You'd probably have to make a derived table with the data laid out the way you needed it. And then you could use some row number functions to let them tell it how many rows they want to grab and do some paging things. We don't have any paging examples, but if you follow up with me with your after the session, I can show you how that would work. Good question. Can't who function?
Range
The,
as opposed to rows, so just 1 month back.
he was asking, how do I automate it? How do I make it, if I don't know how many months back the user wants to look at? So,
I always want to go 12 months back, I just don't know which 12 months it's going to be. And she was starting. So that's what I was.
that's the problem. You have to be able to define your partition, and I'd have to see a better,
Data, D minus 30, is
you would have to construct your base data, it filtered the way you need it first, and then you could do your ranging on obviously they're not going to be simple queries like this. You may have a big derived table or a CTE with the staged raw data in it, and then you could use, if that's staged just so that your partitions work out, that you can do the frames that way, then that works fine. But if you've got several different blocks of data and maybe it's not contiguous, it gets complicated, but there are definitely ways to do it. I misunderstood when I assumed that he wanted the users to be able to say, oh, no, I want 6 months today, or I want 4 months today, and that would require variables passed into a stored procedure and different solution altogether. So the takeaway from all of that dialogue that I'm not sure everybody was following is that these are dead simple examples. They're not real world. They're not the kinds of things that you're going to be doing from a day-to-day basis. You have complicated data. So you have to think about, how do I create my staged set that I want to do these window functions on? Window functions operate on the select output only. So if you can get a temporary table or a CTE with the data in the shape that you need that works for your partitions, then you can use the functions on that derived table. Does that make sense? You have to be creative and really think about how trying to figure out how the partitions work to solve your problem. Wow, we could do a whole day. I would love to sit, if people like just bring their queries, how do we fix this? And just do a demo like that. But so I don't know how we could pull that off. But there's so many different ways to solve the problem. And it always comes down to the business rules. And that's why we always say it depends, because there's no way to know. So that was some. Let me make sure that I told you everything I wanted you to. Okay, the point of that was to show the flexibility that we have over the range. It's not just about range and row, values and position, but we can actually control the value that we're pulling back to a very fine degree. Yes? You cannot do distinct in window aggregates. So if you needed a distinct, you'd have to do that in using group by, or you would have to remove duplicates using some of the row number techniques that we're going to look at. So there's some ways around it, but you can't do a distinct, you can't do count distinct star over. That won't work. It'll bark at you. So let me close all of these. We've got time. Save changes, yes. Close. And that was demo 2. We need demo 3. All right. This is where we're going to talk about combining some of our aggregations. Remember when I said that the window functions work on the select output? When queries are processed, they go through stages of logical processing. You start with your from. We grab the raw data from the tables. We make a Cartesian product. We throw out any non-matches based on our joins. And then after that virtual set gets passed down to the where clause, anything that needs to get thrown out there happens, and so we further reduce our set. And then if we have group by or having, additional filtering happens until we finally, after we've done all of that, get down to the select phase where we're actually generating our output for the query. So all of the processing that gathers the data, the index scans and the seeks and the lookups, all of that's happened already. So we're just now, all the work's been done already, and we've got our final output. It's like somebody went to the grocery store for you, lined up all the food, chopped it all up, had it ready to go in the little containers, and all you had to do was go and cook dinner. It's kind of cool. That doesn't happen that way very often. So because the set of data that we're going to work with is already established, I can combine different window functions within the same output and not have to double dip. Let me see if I can explain what that means. In this query, same query that we've been working with, we've got our daily total, but I also want to see the monthly total so that I can calculate a percentage. So I had to partition, the frames are the same, but the partitions are a little bit different. I want the entire frame, I want the entire partition, but for daily total, I need to order by arrival date and time because I want to reduce it to just that one arrival date. And on monthly total, I don't want to partition at all because I want the entire group. Does that make sense? Okay. Yep. Yeah, it's completely contrived for 1 month. If you needed to, you'd put a where clause in and say where month between 9/1 to 9/30 or whatever your variables that you're feeding in. Again, that goes back to creating the base data that you're working on ahead of time. Good question. So F5. Now I can see where, when I get down to 922, my daily total for 922 changes, but I've still got my monthly total here. And again, I've just combined my aggregates, and I should have turned my execution plan on, and I'm going to do that now and rerun this. When I look at this plan, I'm going to zoom, see how good I am at zoom it today. All right, this clustered index scan. That's the hit to the table to pull the data back to create our working set. Now, this lazy spool and this lazy spool are just workers that are hanging out there processing the window function for us. They've got all the data that they need already from the original index scan, So they don't have to go back, they don't have to double dip. They can do what they need to do because they've got everything already. Does that make sense? I'm not going to go into tons of details about the execution plan, but I can definitely, the point here is that there's only one index scan happening. So if we do this the traditional way using group by, I'd have to use two subqueries. I'd have to use one to make the daily total and one to make the monthly total. And when that happens, here's my subquery here for daily total. I've got a scalar subquery, and it's correlated because I want, for my daily total, I only want to sum up the sales where the arrival date matches. My second scalar subquery is not correlated because I want the sum of the entire set. Does that make sense? This can get tricky if you're not used to using subqueries. But when I run this, I do get the same results. Looks exactly the same, but when I look at the execution plan under the covers, come on, control one. There we go. I've got 3 index scans. So those subqueries have to be calculated completely from scratch. They don't know anything about what's in the result set yet. So that's the answer to your question, why wouldn't I just use group by? It depends on if it's just one thing that you need to group by and the table, you're just having one index scan either way and the code's cleaner, use group by if that's all you need. But if you need to combine aggregates on your data, see if you can do it within your window because it'll save you I/O. All right, so did that make sense? So we talked about one of the benefits of window aggregates being that they work across the set of data and you can control how we calculate things in buckets. This is one of the optimization things that makes Windows so efficient because we work on the final output. We're not having to make additional hits to the database itself each time we want to calculate. The query itself, yes. So that was demo 3. And for demo 4, we are going to talk about ranking functions. And these are going to be fun. I like these. Do I want to open all of these at once? Let's do it. I should remember to practice on my tiny screen. I had this all, I had side by side so you could see the code and see the results, and I was really happy with it, and it doesn't work so well when your real estate shrinks by half all of a sudden, so note to self. Let's go to my first query. Row number. The gentleman in the back there asked about ranking functions and row number, and why not just use row number. In the earlier case, I was really just, even though it was a silly example, I was trying to show count. If I didn't care about the count, I just wanted to assign an ID to it, row number would be the way to go. In this case, remember I said that ranking functions require an order by clause? You can't run them without them. They won't work. So if we don't care about the order and we still want a row number to be duplicated, we just order by this constant. I just tell it to select null, and then I tell it, order it for me. I don't care what order you put it in, but here's a constant to work on. So when I select my data from transaction history small, I've got some transaction IDs and transaction dates here. I tried to keep this as simple as possible. I can see that I've got some null transactions. Maybe somebody's doing some prep work for me. They're bringing data in from a couple of different systems, and they've just dumped it in a staging table for me and said, here, you sort it out. So I'm looking at this thinking, right, I need to add some new transaction IDs to this. So I can use my row number function here to add a new key. So if this were good and I didn't care about the nulls or the duplicates, I could just insert that to a new table and I'm off and running, replace my transaction ID with my new key. But what if I am concerned about the transaction date order? In that case, I didn't care about the order, I just ordered by select null. If I want those results to come in as they arrived, I'm going to have to put order by transaction date in. Does that make sense? If I run this, now I see my row number changed, but I'm start with my lowest date and end with my latest date. And I've got some nulls stuck there in the middle, and I can certainly see that I've got some duplicates. But I still got a new key, and if duplicates are not a problem, then again, I'm just going to insert into the new table, and everything's in contiguous date order. So what if duplicates are a problem, though? Now this is where dense rank can help me. Row number is a ranking function, but it doesn't care about the values. It's kind of like the difference between rows and range. Row number only cares about position. It's just going to assign the next ID as the rows come up. Dense rank is going to look at the value of the order as well. And so anything that has the same value is going to get the same rank. So if I run this, see how all my ordering value was transaction date. All these guys have the same ordering value of 917, so they all got the same dense rank. So now, if I want to get rid of the duplicates, I can put this query, this is why I need them side by side, this guy that we just wrote here to get our dense rank. Easy peasy guy here. We're going to take him and put him in a derived table inside here, name him source data, and now we're going to select the distinct group key as our new key, and we get just the single date value. Does that make sense? So we've just deduped and rekeyed all in the same fell swoop. So let me close all of these. You can do some really neat things with dense rank, and I'm going to show you how to find gaps in your data too. So that, close. I want to talk about deduplicating. In this case, I'm not trying to do anything with the keys. It doesn't matter. I just need to get rid of the duplicates. I'm cleaning up some garbage data. Who knows where it came from. I'm going to use row number. I'm going to order by select null because I don't care what order I put it in. I've got the very similar data to what I was looking at earlier. I know that I've got duplicates in here, and I know that they're duplicates based on date. So when I do my next query, I'm going to partition by transaction date, not order by. This is tricky because I'm not using dense rank this time, I'm using row number. I want to see all of the transaction dates that are grouped together. And again, the order date doesn't, or there's no order here that matters, so I have to tell it this default select null to get it to work. So when I run F5, and if I run the whole query, it works better. Now, I get one row count for each transaction date. And as I get to my duplicates, that's where my row numbers start to increase, because it's going to assign a new row number, yes, for every member of the partition. So, based on that information, when I get to here, I want to, and I really wish it would do this way. Okay, I'm going to close this. Hang on. There. Okay. So now you can see my raw data on this side, and I've put this same simple query here inside a CTE this time. And I did a CTE because we're going to delete against this. It's harder to delete against a derived table. Common table expressions work a lot better for this. There's really not that much difference in the way the query optimizer treats derived tables versus CTEs, so we're not going to go into depth on that. But for this particular technique of deduping duplicates, CTEs are the way to go. So all I've done is take that query that we used to generate the data on the left-hand side of the screen and put that in a CTE called source data. And now I can select everything from source data where row number equals 1. And that excludes the duplicates, because we know the duplicates, we don't need the ones that are greater than 1 because those are the ones we want to get rid of, right? All right, so if we go to our next query here, number 4, I can set up a transaction, and instead of selecting, I'm going to tell it to delete from source data where row number is greater than 1. And I'll just run this. You see why we're deleting where row number is greater than 1? Cool. So then that clears out my list, and we can see I just got 1917 left. So this is a handy trick if you've got to scrub data often. It's quick and dirty, and you just have to know what defines your duplicates, and the partitioning and the ordering can get a little tricky sometimes. So that's a very basic example of that. Let me close this demo. The next one we're going to look at is some temporal data and look at some date ranging and how you can find gaps in your dates. Demo 5. Hello. There we go. Y'all hang with me. We got 10 minutes left still. This is the fun stuff. We're going to talk about lag and lead. These are offset functions. The offset functions are a little funny because they have default frames. That's rows between one preceding, and one following, and one following. That's it. You can't manipulate that. You don't have a choice. So if you need more than that, you're going to have to use a different technique. But in this case, I've got a clean transaction history. I've deduped everything. And for the sake of my example, I'm going to assume that transaction 1 is active until transaction 2 starts. So they're contiguous. Does that make sense? And if I want to get a start date and end date for each transaction, I can pull the transaction ID and set the current transaction to the transaction date and set my next transaction. When I say lead transaction date, order by get me the next date that comes in my partition. And I haven't partitioned by anything because I want the whole set. But I could, again, subset that into the different partitions. So when I run this, I get the current transaction and the start of the next transaction. But that's not really the end date of my transaction, is it? I need it to be one less. So, because I'm the boss and I decided I don't want it to start immediately. I wanted it to be just daily. So I'm going to put the code that gave me the next transaction, again in a derived table, and then put a little calculation on that to just subtract 1 day. And now I've got a nice range for my transactions. 1 started at 7:21 and ended at 8:01, and number 2 picked up from there. Again, we're assuming that these transactions are contiguous, that there's no set interval for them. The next example deals with set intervals. Gaps. In this case, let's imagine that these transactions are only a single day long. So we've got the same data here, but there's not, it went from, 0000 to 2399, and that was it. That's the extent of its transaction. The next one didn't happen until 8:02. And we can see down here as we start to pick up, we start to get multiple days that have transactions back to back, but it's really hard to tell just by looking at this where our gaps are. What were the days that I had no activity? So if I use the same thought process that I did for my date ranging, I'm going to get my current transaction and my next transaction. So I can see here's the first one and here's the second one. I'm going to open this up in a vertical window here, and I'm going to put that query inside a CTE, and I'm going to do some tricks here. Based on this data that I've generated in the CTE, I'm going to declare my range start to be 1 interval ahead of the current transaction, because I know the period of non-activity started the next day, right? And then I'm going to declare my range end to be 1 interval of activity behind the next transaction start, because I know that that's when that activity ended. Make sense? And I put the days apart in here just so you can see how the calculation works for the filter in the next screen. So if I run this, I can see that I've got a transaction. I'm pointing at the screen like you can see me. 7/21 is our first transaction. We know it ended at the end of the day on the 21st, and our next one didn't happen until 22. So our gap of inactivity is from 7/22 to 8/01. Make sense? And we can definitely highlight that by how many days apart this is from this. It's 12 days apart, so I know I've got more than more than 1 day gap is a gap of inactivity for me that I'm concerned about. So in my fourth query, all I do is use that date diff calculation and say where the days apart are greater than 1. Filter those out for me. And then when I run that, I can see my range start and my range end, but only for the ones that didn't have inactivity. So if I scroll down here, where are my January ones? Look, see, they had 1, 3, 4, 5, 6, 7. There were no periods of inactivity there. So when I'm here, I shouldn't get inactivity again until 108. See how that works? I think that's cool. There's some really amazing stuff that you can do once you get your head around how all the dense ranks and rankings work. Yes?
But instead of using day lead and then adding day 1 and -1, can we directly put the lead and line inside the day lead function?
No, because I don't have, let me think about that. Yeah, yes, there probably is a way that I could rewrite that, but I'd have to sit down and play with it. And I want to show you the optimization trick quick. So maybe if you come up afterwards, we can look at that. I don't want to say no right off the bat. I think I see where you're going with that, but it would take me too long to do it and not show you the indexing, which is important. So this one's quick, guys. When we've got 4 minutes, so it's good that it's quick. Demos. Demo 6. Okay, so we don't want to look at this one. Optimization. I am querying against a little bit larger table this time. I've got a store ID, transaction date, actual cost, and I've just got a generic transaction order field that I'm calculating here. When I run this, I want to make sure that I do not have this index because it will mess up the demo. Make that go away. Okay. So my optimization query, and turn on my query plan, go. And 81,000 rows, it didn't really take all that long, but I've got a clustered index scan that went parallel. Sometimes this sort will spill to memory, which was doing on me last night. So this time it decided it could split it across threads, but if you've got a system that doesn't have enough cores or for whatever reason it can't distribute the workload, these sorts are very expensive, and if they spill to temptb, it can be the window functions can seem really cool, but then all of a sudden you've got all of this tempdb activity. So indexing for these operations is important. And the way that works, it calls it the POC index, the partitioning, ordering, and included columns index. So we know that we're going to partition and order on store ID, transaction date, and transaction ID. So we want those to be the key columns for our index. And we know that we're returning, let me put this here so you can see, we are returning actual cost in the query output. It's not part of the row numbering, but it is part of the final output. So we're going to put it in an included column here so we don't have a key lookup on that. So when I create this index and then rerun this guy, still get the same rows, but I've just got a sweet little index scan, no parallelism needed, nothing spilled to memory because it was sorted already the way it needed to be. So that's one way that you can tune these queries if you're excited about them and you have some good places to use them, but they're running like crap. Think about how you're partitioning and ordering and take a look at your indexing structure and see how you can help the optimizer pull the data it needs to produce the results. And that's all I have for today. I've got some questions in the back. come on up afterwards. Thank